is your school on air in Science 7, live at 88.5 DWND FM and CND Cable, Kapit Bahay Channel 8. This is your teacher, Arian Joy B. Nugalay of Cauayan City Science and Technology High School, Schools Division of Cauayan City, Isabela. How are you today? I hope you are doing good, safe, and healthy in the comfort of your home while you are listening. Have you eaten your snacks? Let's have a short review. Do you still remember your previous lesson? In every successful experiments and great inventions that change the world, there are basic steps followed by scientists or inventors. How many basic steps do we have in conducting scientific investigation using scientific method? What are they? We have 6 basic steps. First, make observations. Second, come up with a question. Third, develop a hypothesis or prediction. A hypothesis is not simply a guess. Hypothesis is an educated guess or tentative answer to a problem. We also have variables. What are variables? Variables in an experiment may be independent or dependent. The variable that is being manipulated or controlled is called independent variable. The dependent variable changes because of a test. It is the effect that arises from the changes in the independent variable. Afterwards, we may now conduct an experiment or test the hypothesis. Then, record and analyze the results. Lastly, we have drawing conclusions. To pave the road in our journey, we have to be guided with the following objectives. First, use the scientific method in solving problems through an experiment. Second, relate scientific method in daily life.
Fasten your seatbelt and let's watch this short video clip.
Clarendon Learning explores the scientific method. If you wanted to go to Disneyland and didn't live in Anaheim, California, and had never been there and didn't know the way, but wanted to go so bad, how would you get there? Okay, probably by car, but what direction would you go? Which roads would you travel? Okay, some of you may have said, I'd Google it. Sure, that's one way. But say you don't have Google, and you don't have a smartphone. What do? Maybe you said a map. Well, that's what I would use. I'd use a road map and follow it, and with a little luck, arrive at Disneyland. There you go. I also might need a compass. Now, scientists are always curious about the world and how everything works and why it works. And they are interested in inventing new things and making things that have already been invented even better. While scientists are doing their work of discovery and experimenting, they use a kind of roadmap. It's called the scientific method. The scientific method is a series of steps to perform to figure things out, to get to the bottom of things, to discover the answers to the questions of what and why and how things work and to make them work better. Look at a light bulb. Not an LED, but an incandescent light bulb, one that has a glowing filament. How do you think we got the light bulb? The light bulb was not invented by just one man. The development of the light bulb took many years and many experiments, and many men all working the scientific method to invent one of the most important discoveries ever. Can you imagine what it would be like if we did not have the light bulb? We'd have nothing to wrap around the Christmas tree to make it glow through the night, and you would probably be tripping around in the dark if you didn't have a flashlight. And without the light bulb, you don't have a flashlight. The scientific method, when followed properly, can help you figure out the answers to some important questions. Let's look at the steps of the scientific method. Step number 1 is observation. If you're like a scientist, you are naturally curious about the world, aren't you? Maybe when you were younger, you were always asking adults questions like, why is the sky blue? What makes water freeze? What makes lightning? Why do my bicycle tires always go flat? What happens if I touch a hot stove?
Hey, don't touch that. You'll burn your fingers.
As you looked at the world around you and wondered about things, you were observing. Observation is the first step of the scientific method. Observation requires using one or more of the 5 senses. What are the 5 senses? Hearing, seeing, smelling, tasting, and touching or feeling. And then asking the questions or questions, why or how. Asking yourself these questions will lead you to the second step of the scientific method. The second step in the scientific method is to form a hypothesis. An hypothesis is an educated guess or a statement. Usually, your statement will go something like this. If I do this, fill in the blank, then I believe this, fill in the blank, will happen. You may not come up with the correct answer at first, but making a guess is a good start. Your guess needs to be able to be tested by other people. Yes, testing. Testing your hypothesis now leads you to the next step in the scientific method, which is to experiment. Experimentation is the third step in the process of the scientific method. This is the fun part. Your experiment may fail and may not support your guess or your hypothesis, or maybe it will. As you test your hypothesis through experiments, you will want to conduct your experiments carefully each time. If you don't get the desired response, you may have to slightly tweak or adjust one of the characteristics of your test. It takes great patience as you go through the experimental phase of the scientific method. Other people who want to test your guess or your hypothesis will need to conduct the experiment the exact same way. Regardless of the result of your experiment, it will lead you to a conclusion. Conclusion, the fourth step in the scientific method of discovery. Your conclusion may be that your experiment supported your hypothesis, which may lead to more questions, or your experiment did not support your guess, your hypothesis. In that case, you will need to conduct further experiments until you get a satisfactory answer, which may still lead to other observations as you continue your path of discovery through the scientific method. It's important to keep a notebook and keep a record of your findings as you follow the steps of the scientific method. Let's run through a simple exercise to see how using the scientific method can work. There are many areas in the U.S. where winters can be brutally cold. Water freezes at 0 degrees Celsius. That's 32 degrees Fahrenheit. And if it happens to rain, the water turns to ice and snow. That's great for sledding and boarding and skiing, but not so cool for drivers. And roads can be very treacherous and dangerous when they're icy and slick. You may have seen snow removal trucks shoveling snow and spreading salt or sand on the highway to melt the ice. There is your observation. It looks like salt melts ice. But how much salt does it take to melt the ice? And how much salt does it take to prevent water from freezing? There is our step 1, using the scientific method. Our observation. Now on to step 2, the hypothesis. We are going to make a guess. This might be our guess. If I use just a little salt, then the ice will melt. This could be our hypothesis. Or maybe you've come up with one on your own. There! Finished with step number 2. What's step number 3? Right! Experiment! We are going to test our hypothesis. Our experiment must be carefully planned. It must be able to be accurately repeated and be able to perform by someone else. Maybe this could be your experiment. We could use a plastic cup or a plastic bowl or a paper plate. Why are we going to use plastic? Because glass breaks. Glass is dangerous, guys. I'm going to use a paper plate and put in some regular tap water. Next, place your cup or bowl or paper plate of water in the freezer and give it time for the water to turn to ice. Remove the ice from the freezer and sprinkle a little sodium chloride, also known as salt, onto the ice and observe. See if the ice begins to melt. How much salt did you use? How thick is your ice? Whatever you do, you will have to keep precise notes. A lot of notes. There is no limit to the number of notes and explanation to give to your experiment. And now, what would you do next? Well, maybe you would return your container to the freezer and see if the salty water refreezes. You can run your experiment any number of ways. More water, less water. More salt, less salt. At the end of each experiment, you can come up with a new conclusion. See if your experiment can be repeated and determine if the salt is an effective way to melt ice. The point is to follow each step in the scientific method until you reach an answer, an acceptable conclusion. Back to the light bulb. Of the several men who took part in the development of the incandescent light bulb, Joseph Swan, Hiram Maxim, and Thomas Edison, it was Thomas Edison that developed a practical, long-lasting bulb. Thomas Edison tried 1,000 different ways to make an acceptable filament. When he was asked how it felt to fail so many times, Thomas Edison replied,
I have not failed. I've just found 10,000 ways that won't work.
Now that's the attitude to have. All right then, go to it. Observe things. Hypothesize, experiment, conclude, invent things. Make this world a better place. You were born to do it. And now while you're at it, check out the Clarendon Learning Activity page for more great experiments using the scientific method.
Now, turn to page 8 of your module and let's have an experiment. Before we proceed, here are the things to remember. First, get all the materials needed, like a slice of apple, a spoon of water, a spoon of milk, a spoon of soda. Second, dress appropriately and wear your mask. Third, be attentive. Fourth, do not eat while conducting the experiment. After completing the experiment, carefully clean your workspace, the materials, and wash your hands. Now, let's start the experiment. You were given 10 minutes to finish the experiment and answer all the questions. Let's try to answer the following questions. First, what is the problem in the activity? The problem in the activity is to figure out what can you put on an apple slice to keep it from turning brown. Second, what is your hypothesis? List down at least 2 hypotheses. First hypothesis, if water was added to an apple slice, it will turn brown. Second hypothesis, if milk, lemon, and soda was added to an apple slice, it will not turn brown. Third, what is the dependent variable? Fourth, what is the independent variable? Fifth, analyze your results. Which type of liquid will prevent from turning brown? A lemon, a milk, a soda, or a water? At this juncture, let's check what you have learned. You have to read the paragraph carefully and identify the correct words that fill in the given sentences inside the box. Write your answers on a separate sheet. During a simple scientific investigation on a specific problem in your area or at home, write it on your science notebook. For example, you turn the light switch on and the bulb does not light inside your room. Use a scientific method in your investigation. Describe each step that you will do to solve the problem. That ends our discussion on components of scientific method. Prepare your quiz notebook and let's have a short quiz. Let us see if you understand our lesson.
Listen carefully and choose the best answer by writing only the letter in your quiz notebook. Number 1. What skill is used by a scientist when he or she listens to the sounds that are produced by wheels? Letter A. Interpreting data. Letter B. Drawing conclusions. Letter C. Making a hypothesis. Letter D. Making observations. Number 2. What is the correct order of the steps in the scientific method? Letter A. Ask a question. Analyze results. Make a hypothesis. Test the hypothesis. Draw conclusions. And communicate results. Letter conclusions, make a hypothesis, test the hypothesis, analyze results, draw conclusions, and communicate results. Letter C. Ask a question, make a hypothesis, test the hypothesis, draw conclusions, analyze results, and communicate results. Letter D. Make a hypothesis, test the hypothesis, analyze the results, ask a question, draw conclusions, and communicate results. Which of the following hypotheses is written correctly? Letter A. If frozen tennis balls will not bounce as high. Letter B. If I heat up a tennis ball, it will bounce high. Letter C. If I freeze a tennis ball, then it will not bounce as high. Letter D. If a tennis ball is frozen, it will not bounce as high as one that is not frozen. Number 4. A scientist conducted an experiment to determine how the amount of salt in a body of water affects the number of plants that can live in the water. Which is the independent variable? Letter A. Water. Letter B. Temperature of the water. Letter C. Amount of salt in the water. Letter D. Number of plants in the water. Number 5. A scientist conducted an experiment to determine how the amount of salt in a body of water affects the number of plants that can live in the water. In this experiment, which is the dependent variable? Letter A. Water. Letter B. Temperature of the water. Letter C. Amount of salt in the water. Letter D. Number of plants in the water. What is the last step in scientific method? Letter A. Writing report. Letter B. Collecting data. Letter C. Analyzing data. Letter D. Drawing conclusions. Number 7. Why is experiment important? Letter A. It helps create jobs for scientists. Letter B. It creates more questions to be answered. Letter C. It ensures that many tools are used safely and accurately. Letter D. It allows for new discoveries and knowledge in science. Number 8. Why is scientific method an important process in doing experiments? Letter A. It takes more work, but it is worth it. Letter B. It helps the experiment to take longer and be better. Letter C. It ensures that the results can be trusted and repeated. Letter D. It ensures that the people doing the experiments are scientific. Number 9. What skill is involved when you use fine senses to gather information? Letter A. Observing. Letter B, posing questions. Letter C, developing hypotheses. And letter D, designing experiments. Number 10. Which step that follows formulating and objectively testing hypotheses? Letter A, interpreting results. Letter B, stating conclusions. Letter C, conducting experiments. And letter D, making observations and collecting data. Number 11. What do you call a series of logical steps that is followed in an order to solve a problem? Letter A, model method. Letter B, scientific theory. Letter C, scientific method. And letter D, experimental process. Number 12. How do scientists test their hypotheses? Letter A, designing models. Letter B, doing experiments. Letter C, drawing conclusions. And letter D, formulating questions. Number 13. What do you call the information gathered during experiments? Letter A, data. Letter B, theory. Letter C, conclusion. And letter D, hypothesis. Number 14. What step should be completed first to solve a problem? Letter A, analyzing data. Letter B, drawing conclusions. Letter C, testing a hypothesis. Letter D, recognizing and identifying the problem. Number 15. Which of the following steps to solve a problem must be completed last? Letter A, analyzing data. Letter B, drawing conclusions. Letter C, testing a hypothesis. And letter D, recognizing and identifying the problem.
That concludes our lesson for today. Always remember that scientific method helps many scientists in solving problems and in making their experiments. But not only scientific problems can be solved by its steps. It has also the potential to help us to be successful in our everyday life. Until next time, once again, this is Teleradyo-Isabela. I'm your teacher on